When you order an upgrade for a 9000 panel, you're going to receive 3 chips. The first of those chips is going to be this firmware chip. This firmware is just going to go right here in the 9000 panel. You also receive 2 application chips. One's a 512 application chip and the other one's a 256K application chip. Now which one of these chips you use is going to be dependent on what Rev 9000 board you have. If you look right here above this switch, it's silk screened right here on the board. So in this case, this is the 9000 CPU Rev L board. Now sometimes this barcode label is actually over top of the letter here, so you might have to peel it back a little bit to see it. Once we've identified which Rev board we use, we're going to look at our documentation that comes along with those chips, and we're going to see Rev M, Rev L, and pre-ETL boards. If we look at the Rev L board, it's going to tell us we want to use a 256K chip. The Rev M board uses the 512K chip. So now that we've identified what Rev board we have, as well as what chip we need to use, we're going to completely power down our panel. Now before I do that, I want to remind you that up until this point, Identipass is still running. This 9000 panel is still being used by Identipass. It's still granting and denying access at doors monitoring points. Once we remove power and start changing chips, this panel stops working with Identipass. However, because we've already set up Premises and we've already configured the hardware, we already had the Premises controller installed and downloaded with all the pertinent information for this particular 9000 panel. As soon as we get the chips replaced, readdressed, rewired to communicate with the Premises controller, this panel is going to start functioning again. So the clock starts ticking as soon as we remove power from here. So we're going to disconnect battery backup, we're going to disconnect the power supply, and we're also going to remove this lithium battery. This lithium battery is no longer needed because the memory is actually stored on the Premises controller. So we can discard that. Now we're going to replace the application chip. If you have a chip puller, you want to use a chip puller to do this. My guess is most of you guys don't carry chip pullers, so I'm going to show you how to do this with a screwdriver, because in reality that's probably how you're going to do it. You just want to slide the screwdriver underneath the chip, between the chip and the socket, gently work that chip out of the socket until it's free, and then we've already identified that we're going to use the 256K application chip on this panel because it's Rev L. If you've never stuck a chip in before, you want to take your chip, find a hard surface, and roll into the legs just a little bit, just like I am here, to straighten these legs out. When you get them, the legs are flared a little bit, and this just makes it easier to put into the socket. Another thing you want to check is, on the left-hand side of the chip, there's a notch. On the left-hand side of the socket, there's a notch as well. You never want to rely on the label being on properly. With any chip that you put in, you always want to check the socket and the chip and make sure those notches line up. So we're going to make sure our legs are in place. We're going to firmly push that chip into the socket, taking care that we don't bend any legs out underneath or out of the socket. Now we're going to replace the firmware chip. If you look here, the socket's actually larger than the firmware chip. There's 2 empty holes to the left of the socket, in the socket, and we're just going to pop this firmware chip out the same way, and when we stick the new firmware chip in, we're going to make sure that we leave those 2 empty holes to the left of the chip. So our firmware chip is out. We're going to grab our new firmware chip. Again, we're going to roll our legs a little bit to make it easier to install. We're going to line our legs up, check our notches, make sure they're both on the left-hand side there. We've got our 2 empty holes on the left, and again, we're going to firmly push that chip into place, making sure that we don't bend any legs out. So now our firmware is in place, our application chip's in place. Next thing we want to do is we want to rewire our communication line. The 9000 panel uses 4-wire RS-485. The Premises hardwire uses 2-wire 485. So we're just simply going to remove the wires out of 3 and 4. I've already made some jumper wires here, and we're just going to jumper pin 3 to pin 1. And these jumper wires are only little pieces of wire that I've stripped both ends off of. They only need to be about 1.5 inches long, and you can make these up ahead of time so that your downtime with your panel isn't affected. So 1 and 3 is jumpered out, and now we're going to jumper pin 2 and 4. Our drain wire is going to stay in there in pin 5. And we have to do this at any 9000 panel that we change over to work with premises. And so we've got 2 and 4 now jumpered out, and 1 and 3 jumpered out. And we're going to want to finish these wires up here. We just don't want to leave those hanging there in your installation. So now our communication is rewired. The next thing we want to do is we want to refer back to that document that came along with our chips. And on the second page, there's a clearing memory section. And we want to read here, we need to turn dip switches 7, 8, and 9 off with power off of the board. So 7 and 8 on Rev L. Rev L does not have a switch 9. And then we need to power up our board. So we're going to apply power. Once power is applied, we need to turn switch 8 on. We need to press the reset button. And the reason we're doing this is because removing power and replacing the chips doesn't completely erase the memory. So we have to run this routine to completely erase it. Now all 8 of our relays energized. So now we need to turn switch 8 off according to our instructions. Press the reset button again. Our 8 relays go off. Now we know that our memory is completely erased. We can also hook up our backup battery. And then the last thing we need to do is we need to readdress our 9000 panel here to work with premises. In the software, we address the panel as panel number 1. So we're going to look at our dip switch settings from our premises manual. It's going to say address in a premises system for a 9000 board. Come down to panel number 1. Switch 1 on, 2, 3, 4, and 5 are off. So 1 on, 2, 3, 4, and 5 are off. We're going to hit our reset button, and then if we've wired everything up correctly, all our pins are in place, our 2 LEDs up here, we should start getting a green and red transmit and receive light, which we do. So now we know that we're communicating properly. I also hooked up a test reader right here at the panel, and when I read my card, my relay just energized, my card worked, I didn't have to go back to the software and re-download. My panel is now up and running with premises, and the only time that this panel was down was the amount of time that it took us to do what we just did here in this video.